Very good afternoon to all of the B.Sc first year students of analytical chemistry. Once again, I welcome all of you to our online class. In last lecture, we have learned about the topic, that is principal construction and working of double pan analytical balance or equal arm analytical balance. Today, we are going to learn about the principal construction and working of single pan analytical balance. So let's see what is the difference between single pan and double pan analytical balance, how this single pan analytical balance is superior in weighing than that of the double pan analytical balance. In single pan analytical balance, we have only one pan, that is what the single pan, that is what the single pan instead of the two pans, and we have only two knife edges instead of we have three knife edges in the double pan analytical balance. So the single pan analytical balance was first introduced for the weighing in 1946. So these balances have only one pan, that is single pan, and a beam only two knife edges. This beam with the two knife edges, here one is knife edge and here second one knife edge, is a single pan. Then weighing with such a balance is easy, speedy and convenient. So it is what weighing with this type of balance is easy, speedy and convenient. Hence it is superior than two pan or double pan analytical balance. So this is the significance of that single pan analytical balance. Then single pan analytical balance, what is the principle of construction and working for this single pan analytical balance? The principle of construction of two knife edge single pan balance can be illustrated by the simplified line diagram. This is what the simplified line diagram of single pan analytical balance. So the simplified line diagram of two knife edge single pan analytical balance, here is the one A is the one knife edge and here B is the second knife edge, and this beam AC is the horizontal beam. So essentially a single pan balance is a horizontal beam AC fixed with only two knife edges, one at the left end of the beam, that is what left end of the beam, and second at the center of the beam, that is nothing but B, but not at the exact center. At the right end of the beam, instead of knife edge, there is a permanent counterweight and air damper or dash spot which forms the part of horizontal beam. This is what the air damper and dash spot instead of the knife edge in a single pan balance rather than that of the double pan balance. So the two arms of the balance are unequal. So it is not equal arm balance, it is unequal arm balance, because these two arms are not equal, they are unequal in the length. So the left arm is shorter and the right arm is longer in length. So this left arm is shorter and while this right arm is longer in length. Then shorter and right arm is longer in length. Both the carrier hanger with full set of weights and single pan along with the struts are suspended from the same knife edge A on left and the beam on right end of the beam. So there is on the left hand and on the right end of the beam there is a rigidly attached permanent counterweight and air damper dash spot. So what happened? See here what the counterweight is attached to this struts, and this pan is also hanged with this struts, and this struts is what, or this agate is what the resting on the knife edge, that A in the left arm of that single pan balance. And to the right hand side here what one is the counterweight, C counterweight is there, and dash or a dash spot or the air damper is there at the left hand side. So hence the empty balance is fully loaded and weighing is done by what the substitution, leaving the same load on the beam at all times. In a release position, the beam of the empty balance is horizontal equilibrium position. So what is the principle? We remove the weights. We keep the weight in the given pan. Then this beam is what tilted toward downward, and this beam is what retained to its original position at the horizontal position by means of removing these counterweights, which is equal to the weight of that object placed in the pan. So when object to be weighed is placed on the pan, the left end of the arm moves downwards and the equilibrium position of the beam is displaced. To restore the beam to its original equilibrium position, an appropriate set of weights are to be removed from the carrier suspended from the same knife edge E, where pan and consequently object are also suspended. So this is the procedure how to measure the what the how to measure the mass of an object by using the single pan balance. Keep what put the object in this pan, then this beam is what moved downward, and the equilibrium, that is horizontal position, is get disturbed, is displaced by means of the keeping object. Then to what bring this beam to its original position, we what remove some weights that's equal to the weight of that or mass of that object are removed, and this horizontal beam is what bring to its original or extreme position. Then after this, what the displacement in equilibrium position of the beam is proportional to the mass of the object placed on the pan. To restore the beam to its original equilibrium position, the same mass is required to be removed. So hence the mass of weights removed to restore the beam to its equilibrium position will be equal to the mass of the object placed on the pan. So whatever the weights removed from the hanger is equal to the that mass of that object. Then construction and working. Essentially, a single pan balance consists of lightweight horizontal beam AC supported on the planar surface by central prism by prism type of knife edge B. The knife edge B divides the beam into two unequal parts, namely a shorter left arm and AB and a longer right arm BC. On the left end of the beam there is a knife edge A. On this knife edge A, both the carrier and hanger with a full set of weights and single pan are suspended by means of straps. The weights suspended on the carrier hanger can be removed from the carrier hanger one at a time, one by turning a cam actuated levers controlled by four knobs, a mechanical arrangement that is controlled by the set of knobs on the outside of the balance case in a desired manner. The weight in any combination can be removed from the carrier hangers by set of cam actuated levers controlled by the four knobs. All the weights are in the form of annular rings. A set of dials in front side shows the sum of the weights removed. So with the help of this we can remove the weight and bring the this beam to its original position. On the right end of the beam there is a rigidly attached permanent counterweight C of such a size as just balance the pan and weights on the left end of the beam. Hence the empty balance is fully loaded and weighing is done by substitution, leaving the same load on the beam at all times. An air damper, also known as dash point, is mounted near the right end of the beam. This device consists of piston that moves within a concentric cylinder attached to the balance case. Air in the cylinder undergoes expansion and contraction as the beam is set in motion. The beam rapidly comes to rest as a result of this position or to motion. So this is about the what construction and working of the single pan analytical balance. Here what simply if you are going to see what is the construction and working, simply this is the horizontal beam AC. It is in uh, what lightweight beam on which two knife edges are there. At the left side one knife edge A, which is what suspended with the struts, and what this struts is further what attached with the pan and the counterweight, then pan and attached with the weights, and these weights are removed by means of the weight of object, and the central knife edge the beam is resting on the knife edge B, which is what divides this beam into unequal parts. The shorter arm, that is left arm, and the larger arm, that is right arm. The shorter arm is AB, and the larger arm is the what BC. That BC arm is attached with the air damper and dash points and counterweight to what the maintain the balance of the beam. Whatever the weight of this weight of or mass of the object which we will have to determine is based on this span. Then this what happen, this equilibrium position of this beam is get disturbed, and this beam what moves towards the downward, and this after what moving this beam toward downward, and to bring this beam to its original position, we want to what remove some weights that is equivalent to that weight of that what the object, and after removing this weight we'll get the this what bring we can bring this beam left arm of this beam to its original position, and due to movement of this gas cylinder what moves and the compression takes place, and this helps to maintain the what overall the uh, equilibrium position of that beam, and what the amount of weights are removed from this hanger is equivalent to the weight of that object placed in the mass. This is about the what all over the construction and working of this single pan analytical balance. If you have any queries regarding this topic, please put your questions on the question box, YouTube comment box. I will try to answer. Have a nice day. Keep watching video. Thank you.